for us here. As long as you pretend like I am very enthusiastic, we'll go quickly. Y-intercept. Let me find. Tell me where the y-intercept of this graph is. 2. All right, now if you can write y equals 2, I'm okay with that. How would you write that as an ordered pair? 0, 2. All right, I want to make sure that you can identify the difference between the x-intercepts and the y-intercepts. So y-intercept would be 0, 2. What about the x-intercepts of this function? You're going to have to count for a second here. Where are those two x-intercepts at? -6. So I'm going to write it as an ordered pair right now, -6, 0. But it's totally okay if you write it as -6. Where's the other x-intercept at? 4, 0. Okay. So this graph has two x-intercepts. What is another name? There's a couple of them that we can give to x-intercepts. One starts with a Z. I'll give you that hint. Zeros. What's another one? Starts with an R. Roots. Roots, zeros, x-intercepts, they all mean the same thing. Solutions is another name. So you might hear x-intercepts referenced in those ways throughout the year. Just make sure you know that they all mean the same thing. Now, this one says, on the interval from -1 is less than x is less than 2, is the function increasing or decreasing? So today we're going to show you a couple different times to talk about increasing and decreasing functions. This inequality has an x in the middle. So it means as I look on the x-axis, if I start at -1 right here, I'm going to draw a line so you can kind of see. So between -1 and x equals 2, in that blue colored in region, what's happening to your graph there? It's going up. It's increasing. How can you tell it's increasing? Yeah, because it's going up from left to right. Like going down would mean it would have like a negative slope. Now, let me ask you this question. For my interval of increase, I have less than symbols and not less than or equal to symbols. All right, so if I'm looking from this point right here to this point right here, why do you think I'm using less than symbols and not less than or equal to? Any ideas why I can't put 1 is less than or equal to x? Like that? Why that's not okay? Well, over here it does keep going. But if I'm at 1 right here, -1 right here, and I'm at that point, am I increasing right there at that point? No, I'm decreasing until I get there, and I stop, and then I start increasing. So if I put an equal to for this point right here, that would mean that at -1, at that ordered pair, I'm actively going up. But that's not happening. So anytime we talk about an interval of increase or an interval of decrease, you have to use less than symbols. Okay, so that one's going up. Let's look at the next question. Now it says find the interval where f of x is greater than 0. Right? So f of x, that means y. Right? That's our y value. So we want to know where are all the y values greater than 0. Well, 0, what part of the graph do you think that that's referencing? When I say where is it greater than 0? All the positives. Where are you above the x-axis? So that's what that's saying. Where are you above the x-axis? Where are you positive? Well, what x value do I start at over here? Where do I start being above the x-axis? -6. So I'm going to write this in two ways. I'll do an inequality first. -6 is less than x, and this time I'm using less than because the symbol right here is a strict inequality. If it said equal to here, I would use equal to, but it says less than. And then what x value do I stop being above the x-axis? 4 is less than 4. Now you can write these intervals as an inequality. You can also write them in interval notation. You just had that on your quiz. So if I did an interval notation, would I use a parenthesis or a bracket? Parenthesis. Less than symbols, use parentheses. -6 to 4. Now, the only thing is, I will always make clear if I'm talking about an interval, if it's like a question or something, I'll always write it this way because these tend to look like ordered pairs. But you're welcome to write your answer like that. I'll know what you're talking about based on the context. But If like you're worried about it looking like an ordered pair, just write an inequality. But either notation is totally fine. All right, next one. Oh, look at your pretty faces. No, sorry. There we go. I bumped the wrong thing. All right, now we're going to find the coordinates of relative maximums. Those are your peaks, like a mountaintop, the peaks of your graph. So on here, do I have peaks? Yes, I have two of them. A peak here and a peak over here. Where are those peaks at? Where is a relative maximum? -4, 6, that's right. And where's the other relative maximum? It's like 2, 2, 8. All right, those are our peaks or our mountaintops. That's what the characteristic of a relative maximum is. We also have relative minimums, which are your valleys of a graph. So that's where you go down and then you come back up. So we only have, how many valleys do we have here? There's only 2 valleys. 1 and 2. This one doesn't come back up on the other side. So we have 2 valleys there. And this first one's at -1, 1. That's the left one. Where's the right valley at? Where's the other ordered pair? Not 4, I think it's 5. Yeah, 5, -2. So when you have relative maximums and minimums, you have to change direction. Or you have to go up and then come back down for a max, or have a valley like that. Now that's different from the next question, which is asking us, where are the absolute maximum and minimum values? Well, what do you think that word absolute in front wants to find for you? What wants you to find? Yeah, give me another word, a synonym for absolute. What does that mean?
Single one.
The what? Okay, single one. Well, why would I say absolute? How is this absolute different than this one? Well, yeah, so it's the highest. It's the very highest one, or the very lowest. So the absolute one is the very highest or lowest point. Okay, so you want to find the one point that is most high on your graph. Where is that absolute maximum this time? What ordered pair? 2, 8. That's right. Now this time, that did happen to be. That was also a relative maximum. That's okay. It can be both. Where is my absolute minimum? Where's the very lowest point on this graph? You tell me? Negative what? And this one's the very lowest. It's lower than all the rest of them. At what ordered pair? Our enthusiasm is waning. -8, -4. Now, this one is an absolute minimum. It is the lowest point. But this one was not a relative minimum. So you can be both, but you don't have to be. Now, domain and range using interval notation. Some of us had some goofs with interval notation, just even like when I use a parenthesis or a bracket on our quiz. Domain are your x's. So how far left does this graph go? -8. So if you're doing your domain here, there's an end point at the end. So should you use a parenthesis or a bracket? Bracket. Your domain is going from -8, and then how far to the right over here? 6. That's right. And that's your domain. -8 until 6. What about your range? How low do you start? What's the lowest y value? -4, and you are going up to what y value? 8. All with square brackets because the endpoints are closed. Now we have one more question pertaining to this graph, and we're going to create a new, we created a new function, and you're going to look at this new function. So this graph that we've been working with, this is your f of x graph. That's what we've been referencing it as. We created a new function here called g of x. G of x, they said, is 1/2 times f of x plus 2. And it says, what is the y-intercept of g? How do you think we should go about this? I'm going to use this function notation, but I need to put something in for x. Any idea what I should put in for x? What's always the x coordinate of a y-intercept? So if I have a y-intercept, something y, what's always the x value? 0. So why don't we put 0 into g of x for x? That will tell me where the y x intercept. I'm losing my mind. The y-intercept. I told you I need a long weekend too. All right, so let's put this in. 1/2 times f of. Now instead of x, we're going to do 0 plus 2. You can skip that step, but I'm going to write it here in case anyone needs to see what I did with the 0. Well, this now turns into 1/2 f of 2, and I can use my graph of f to evaluate f of 2. What do you get for f of 2 here? We've used that point a couple times today. 8. So it's really 1/2 times 8, which tells me that my y-intercept is at 4. So if I graph g of x using that definition of a function, my y-intercept would be at 0, 4. Okay. All right, so that's reviewing function notation for you there. We good so far? Not too bad on vocab. Here's where your new calculator step's going to come in. Let's flip our page over. We're going to graph a function here. Use our calculator to help us. And this function is g of x equals 2 times the absolute value of x minus 1 minus 8. Do you guys know what an absolute value graph looks like? Bobby, what does it look like? No? Anybody? You might have seen one before. Let's graph it and see what we get. So let's start by pulling out our calculators and turning them on, going to the y equals. So once you get there, if you have an Inspire, it'll be a similar process for you. All right, now when you get your calculators on, let's type in here. So we started with the 2, because your function is 2 times the absolute value of x minus 1. So I'm going to start with the 2, and then I have to figure out how do I put those absolute value bars into my calculator. So here's what you're going to do. You do? How do I do it? You go to math, over 1 to number, so go right to number, and then which one is absolute value? The first one, ABS parentheses, that's short for absolute value. So you're going to hit enter on number 1 then, and depending on your calculator, like on this one, on the screen it gives you the 2 absolute value bars. If I were using my calculator, it would still say 2 ABS parentheses. So it depends on your calculator. Either way is fine. Now we're going to type in the rest of the function. So we had x minus 1. And then make sure, when you do that minus 8 part, you either close your parenthesis or arrow out of the bars depending on what kind of calculator you have. So you'll have minus 8. And then once you use that, you can hit graph. So these absolute value graphs look like a V. Right? Have you seen similar ones before? Yeah, you might not know what it was, but this is an absolute value graph. So we need to graph this on our paper. But we need to be careful here. So before you do that, let's pay attention. It says we're only graphing this on the domain interval from -4 to 7. That means you're not going to plot any points at x equals -5 or 8, anything beyond that. So when you go back to your calculator and you get to the table so that you can plot some of these points, just start at -4 and then plot until you get to 7. All right, and then we'll put endpoints at those. So go ahead and graph that. I'll give you a minute or two to graph those. We're almost done, you guys. All right, so let's do another interval of increase. Where do you start increasing on this graph? You can look here and notice that you're going up on this part. What x value do you start going up at? 1. All right, so I'm going to do the inequality first. So we say 1 is less than x We always use x values for increasing because you're reading from left to right. And remember, we talked about why you have to use the less than. And where do you stop increasing? What x value over here? 7. All right, now, if I was going to write that as an interval with notation there, would I use brackets or parentheses? Parentheses, so I would do 1, comma, 7. That would be my interval there. What interval are you decreasing on? -4, I'll use the interval notation here. -4 until 1. Right, and you could do an inequality too. I'll do the interval this time. Okay, now, domain and set builder notation. What is the characteristic of set builder notation? This was on your quiz you just got back. The little curly brackets. So you're going to do curly bracket. Domain is x values, so we want all the x's such that. Now in set builder notation, we use inequalities. So all the way to the left, what x value are we at? -4. We just did that one up here. -4. Now if there's an endpoint, what inequality symbol should you do? Less than or equal to x is less than or equal to what x value over here? 7. That would be your domain in set builder notation. Then if I do my range in set builder notation, it's going to look very similar, but I need the letter y this time. Now this time, what's the lowest y value you have? -8. It's less than or equal to y. And how high up do you go? To 4. There you go. All right. I'm going to skip D because I'm pretty confident you can state the x-intercepts. Let's talk about E, an interval where g of x is less than or equal to 0. Well, we did one like that on the front. That less than or equal to 0 is comparing to the x-axis. So where are you at 0? That's the x-axis, or below. So that would be this whole part of the graph down here. Well, what x value do you start being equal or less than? How many over? -3. All right, so I will do this. I'll do this as an inequality first. -3. Now, I use less than or equal to here. So what symbol do I need to use in my interval this time? Less than or equal to. Okay, I put my x. And then when do I stop being equal, less than, or equal to? What x value is that at? Less than or equal to 5. Good. Now, if I wanted to write that in interval notation, what symbol would I put around the -3 and the 5? Brackets. Yep. So brackets go with the less than or equal to. All right. Last couple questions about this graph here. We're going to skip F. Let's talk about G. Are there any relative maximum values? So remember, those are your peaks. Are there any peaks on this graph? No. So there are no relative maximum values. Are there any relative minimum values? Yeah, where is the valley at? Yeah, negative, or, no, 1 negative, +1. -8. That's a relative min. So you don't have to have both. You can have just a relative minimum. And let's talk about absolute maximum and minimum. Reese, you can go. We're almost done. We only cut off like 1 minute of the lesson.
Come on, dude.
Absolute maximum. Where is the highest point on this graph? Not negative. +7. Up 4. And what about my absolute minimum? We've used this point a bunch of times too. 1 -8. No. Now, you don't have this on your paper, so you don't have to write it down. But let me ask you this question. If I changed this graph, if we had not restricted the domain, and I put arrows on the edge of my graph, would you have an absolute maximum? Why not? Yeah, because the graph goes on forever. Absolute means there is one very highest point on the graph. That would not have one. We good? We understand this? It was the most thrilling lesson of math you've ever had, correct? Correct. All right.